Hey guys, welcome back to another problem solving tutorial, and in this tutorial I'm going to be showing you guys how to solve problem 155 min stack. Okay, so in this problem it's basically asking you to create a stack class which has the basic operators of a stack. So we can push items in, we can pop items from the top, peek, top is essentially the same as peek, and then get min, this is a special one, but it's basically asking us to find the minimum value inside the stack at any time. So if you don't know what a stack is, it's basically similar to an array, but we can only put in items from the top and take things out from the top. So for example, if we had like something like 1, 2, 3, 4, if we'd been pushing items in like this, then we'd only be able to take it out in this order. So we'd have to take out 4 first, then 3, then 2, like so. So we wouldn't be able to just take out the 2 like that. So anyways, as you can see, I'm just going to copy this in like so. And of course, one thing you might notice is that all of these, the first 3 of these are super easy to implement. Another part of the solution is you have to put in O of 1 time complexity, which basically means you can't have any loops. It has to all be constant time. So one thing you might have noticed is these first 3 are basically already implemented in JavaScript for you. So these will be really easy to implement into our stack as well. So what I'm going to do is I'm simply just going to, we don't need anything for the constructor, but inside the stack we can just create an array to hold the data. So I'll just say something like stack, and it's going to be a number array, and we're going to initialize it as empty. So yeah, we're going to have the stack here and then push. So this is easy, JavaScript already gives us this. We could do this dot stack dot push and just put the value in. Same sort of thing for pop, it's literally just giving you this, so it wants you to take off the top item, I believe. So let's just hang on, let me just see what pop does. Yeah, so removes the top of a stack, so we can literally just pop it like so, and this will do it for us. And same for top, this is slightly different because JavaScript doesn't have it implemented already, but it's really easy. We're just going to return the top item of a stack. So that was just going to be the last item in this stack, which you can get by doing the length of it minus 1. So there we go, we've implemented the first 3 in O of 1 time complexity, nice and simple. But the challenging one is really just going to be the get min. So I'm going to really show you guys an example to understand how this works. Let's just say we were pushing in these numbers. Let's go 6, 9, and then back to 4, like so. Okay, so if we're pushing in these numbers, we're pushing in like this. So we've got 1, 2, 3, and they're going in that order. You might be thinking we can just keep track of the minimum item so far. So let me implement that quickly for you. We'll just have minimum, and we will just set this to negative infinity, or sorry, positive infinity. And the reason we do this is so whenever we add a new one through the push, see this is where we access new items, we can just check if it's bigger, and every item is going to be smaller than minimum of infinity, so that's why we do that. So anyways, we can just do if val is less than minimum, then set this dot minimum to val, like so. And then you might be thinking we can just return this. So I'll show you guys. Dot minimum. Let's give you guys this example. So stack equals new min stack, and we'll do stack dot push 1, 2, 3, 6, 9, and 4. Okay. So obviously when we print the minimum, we're expected to see 1, right? Because 1 is the minimum of all these numbers. So let's see if that works. Stack dot get min, and you see it does work. So we do get 1. However, the problem with this is that, let's say the minimum, so let's say we put minus 5 over here. Obviously now we're going to expect the minimum to be minus 5, right? But if we now pop that, so stack.pop, this is going to remove this -5, but the minimum is still going to give -5. And the reason for that is when we pop this here, we're taking off the top item, but we're not even updating the minimum. And the problem is, even if we try to update the minimum, so the minimum here is going to be 5, right? So even if we know that we're removing that, we don't know if there was a 5 before it or after it. So there's no way of knowing the history, if that makes sense. Which is why the solution, which I think is the best, is to actually hold this history of the minimum as well. So in the stack, we're going to hold the number, but we're also going to hold the current minimum. Because if you remember, the stack can only be inserted in this way. So this is going to have the oldest minimum, then here. So when you get to this element, this is going to be the newest minimum or most recent minimum. So therefore it's the most accurate. And when you remove it, then it's going to be the previous minimum, and so on. So I'll give you guys the example we had earlier. So here, let's just put the minimums. So we'll have nums and we'll have mins. Okay, so when we add 1, the minimum is 1, right? When we add 2, the minimum is still 1. 3, minimum is still 1. 6, minimum is still 1. 9, minimum is still 1. It's just carrying on. And then when we get to 5, now the current minimum is 5. Is -5, sorry. So you can see, if we eliminate the 5 and -5, then we go back to the previous current min, and then we can see it's still up to date. So we're essentially making sure that we're keeping the history, so that if we remove an item, we can always check the previous ones. Okay, there we go. Now we're going to have to update the push function a little bit, because basically we know what the current minimum is. We can do const most recent minimum, and this is just going to be the most recent item on the stack, -1 dot current minimum. And if this is undefined, so actually I'll deal with that. Actually, yeah, we'll just do so if stack dot length, sorry, this dot stack dot length is greater than 1, then we set it to that, and otherwise it's just going to be we'll just set it to val, like so. Okay, so if val is less than most recent minimum, then we set we'll set a new minimum to this. Okay, so const new minimum is equal to, well, if val is less than the most recent minimum, then we're going to set it to val, and otherwise it's just going to be the most recent minimum. Okay, and now we can just push this like so. So number is still val, but the current minimum is the new minimum, like so. Okay, hopefully that makes sense. So we're looking at the previous item's minimum, checking if the current number is less than it. If so, then that becomes a new minimum, like so. Okay, and pop stays the same. Top, well, this only wants a number, so we can just return the number. And for get min, well, we really just want to return the most recent minimum, so we can just do this dot stack the top item on the stack's recent minimum, like so. Alright, so now let's see what this returns. There we go. So you'll see if I print the get min here, it should print -5, but then when we pop it, we go back to this original 1, so we get 1, and that's exactly what we have. So there we go. This is the solution to this min stack problem. Let me just show you guys that it actually works by pasting it in. And there we go. So we get a pretty decent runtime of memory. It's above average, which is always good. But yeah, thanks for watching, and that was how you solve question number 22. Oh sorry, 155 min stack. See you guys in a future tutorial. Bye.